Hello and welcome to another episode of the Security Champions podcast. I'm your host, Dustin Lair, and I am here with Jacob Salassi. How are you doing today, Jacob?
Doing good, Dustin. Thanks for
Awesome.
having me.
I'm really looking forward to this conversation. I do want to share a quick caveat before we get started. The things we talk about are our own opinions and don't represent the opinions of our employers. So with that, we can get started. I really want to learn more about you, Jacob, and I'm sure our audience wants to know more as well. Would you like to just share a little bit about yourself, a little bit of your background, where you're coming from, where you are today, and so forth?
Yeah, I guess I'll talk about my geographic background and then maybe a little bit about my professional background. But anyways, I grew up in Texas. I moved to California maybe, 10 years ago or something like that. I was doing a lot of network engineering, a lot of hacking, a lot of network engineering, and sort of more traditional network support roles. So like what I worked on a long time in Texas were load balancers and network appliances. And there was a lot of, there's a lot of that kind of work there. And that was while I was at Citrix. And then, through hacking and robotics competitions and other things, I was like, I can also learn software engineering and do cool stuff there. And I saw some opportunities from a job perspective to make a pivot in my role at Citrix from a support engineer to a software engineer. And so I did that, but R&D was in Santa Clara. And so to really fully get onto that job, I had to move here to California. And that's kind of, a little bit of my background. Like I grew up in Texas and now I'm from California and fully availing myself of Silicon Valley to the extent that I can.
That's great. Thanks for sharing that. I'm curious, actually, just an initial question, what you consider hacking, because this term is a little overloaded, right? Some people consider it to be one thing, hey, just sort of making it work at all costs. Other people think about it in terms of a purely cybersecurity definition. So maybe you could expand on that a little bit.
I mean, I think about binary exploitation and that sort of thing. So
there you go. Okay.
The security community in Texas. Like I grew up there in the 90s. Like if you've been on a computer for a minute, stuff was going on in the 90s, and that was the time to be learning all kinds of stuff about what was going on in 2000s and into the future. But exploitation and that kind of stuff was like a huge part of the DEF CON scene was large in Texas. The 2600 scene was very big in Texas. And there were a lot of people doing network engineering, SOC. You have Perot Systems, Dell, other major EDS, huge managed service provider community. And from that, you have tons of pen testers, security people, like super healthy community. So like that was the main thing that I did in my spare time and what I was really interested in. But what I was employed doing was network engineering, which was also fun because it had a lot of cool adjacencies.
Fantastic. All right. Well, at this point, we're actually going to pause for a second and hear from our sponsor, but we will be right back. So stay tuned.
Tackle everyday security challenges with confidence. The free Security Champions Field Guide is your practical companion. From input validation to understanding common vulnerabilities and using security tools, this guide has actionable tips you need. Become your team's go-to for secure code. Check the episode description for your free download link.
All right, and we are back. Again, I'm here with Jacob Salassi, and we are talking about his journey, essentially, his background, and what that's become over time as well. So I'm curious to dig into more details around your career path. How did you get started? How did you get into cybersecurity specifically? What kind of roles have you had, and where you are now? And frankly, I really want to unpack this as part of the episode. So I think it'd be good to kind of like pace this. Like, let's spend some time on some of these things because I think it's good for our audience to kind of hear how this evolved, essentially, how your career evolved.
Sure. Well, I guess I'm not going to go like too far back. But maybe, kind of continuing what I said before, I was working, I found my way through various support type roles. So I've been on a computer since I was 10. Use of a computer has evolved quite a bit over time. But at that time, it was, light scripting, not really programming anything, but mostly using computers to be on the internet in the 90s. That's what I spent a lot of my time doing. And so like a natural choice at that time is if like you wanted to get in technology, you got like some Microsoft related certification and did IT support, or you got like a CCNA or a CISSP and then tried to do more networking type stuff, like desktop support and networking were two big things. So anyways, I was working in that space and found my way to network engineering, which was super fortunate because it's really interesting from thinking like what I was interested in as a hobby and, my personal passions. Network engineering was pretty cool because it's at the intersection of a lot of technologies. And so like, if there's one thing that kind of defines my career progression, just my life in general, is like I like to figure stuff out, and sufficiently motivated, I can figure out pretty much anything. But the trick is it's got to be sufficiently motivating, because if it's not, I'm not doing it. And so network engineering was cool. It was super interesting. There were hard problems. They had high stakes in the sense that like at Radware, we were troubleshooting, if you remember Singular, who later became merged many, many times over, but like we were troubleshooting big time network outages that had big time impact on lots of stuff, and potentially even at that time, like, terabits of traffic and stuff like that. So that was pretty cool. Like those were high. So I got interested in that kind of stuff. I was able to pivot from Radware to Citrix because Citrix had bought a network appliance called NetScaler. And so I was doing a very similar network engineering, customer support network engineering role, where the customers call us to support the product and we're troubleshooting what's happening in their networks. But as I said, this is core infrastructure to their network. And so you're sort of involved in those things. But at Citrix, something that was cool was the product was built on FreeBSD. First in the kernel and then migrated out into user space. So like I was close to the technological evolution of, I have secret sauce in the ASIC and on the chips, that was Radware, to hardware as commodity. I have secret sauce in my use of the hardware. That is, I implement as a kernel mode driver, which means I can hit a higher packet per second versus a user mode driver, which deals with interrupts and other things that fundamentally limit you. So I have secret sauce in my software running on a commodity chipset, so the commoditization bar moves up. But then eventually Intel and other folks like actually offload a lot of that into the NIC itself, and they produce something called DPDK. So the commoditization bar moves up one more time. It's like, oh, you can't have secret sauce in hardware anymore. There are only network applications. So first it's hardware, then it's software and applications, and then it's just applications. And so that kind of eats the load balancer market and evolves it into something much more modular, I guess smaller, it's more software defined networking. Like that whole evolution kind of played out there. So that was interesting. But it's a byproduct that we got a lot of interesting core dumps and packet captures. And one of the things you run into with a system like this is it collects a ton of metrics, it produces lots of outputs, and it's dealing with complex problems. So like getting your hands around, how's it configured? How is it interacting with the customer's environment? What are the characteristics of traffic at this time? Like this is an art that a lot of people do across many networking companies, Juniper, Cisco, lots of people do this, but many of them have already have developed technology that sort of takes that data in and up-levels it. You can think about it as a big data ingestion pipeline and modeling that into useful dashboards so that like for a particular customer's problem, you can get a good look at the metrics and say, I saw the traffic spiked here. I saw that correlated with memory allocation here. I saw we failed to free memory here. Okay, now I have a generalized idea of like, what's the problem that's happening here? But to do that, you got to build software. Like you got to automate that. Like you got to have some plumbing to do that. And so this is where my opportunity to pivot showed up. Like I was doing robotics competition. I had written a lot of C. I was like, this stuff's easy. I had not that was true. I had some conversations with developers who I felt like I knew more about the OSI model and networking than they did. And so kind of putting those two things together, I was like, I'm going to write code here. I don't need to just support this. Like I could write this code. So there became a team that was doing development analysis. And like I had already written a bunch of tools myself to speed up my own work. Like any good engineer does, you automate your work. And so anyways, I started socializing that with a manager there on that team and sort of harassed him into looking at my code and giving me a role on that team. And I did that. So I think the thing I'm trying to highlight is like Citrix was super good to me, and I pivoted many times, and I was able to do a lot with my career there, just motivating this kind of stuff. So I harassed him with the code. I pivoted onto that development analysis team. Citrix had a broader concept of maintenance as an externalized entity, like Q&A is a different team, maintenance is a different team. I'll save my criticism of such a model for the future, but like suffice it to say, like that's kind of the next step. If you're the front end of things looking at what the customer gives you, that's support. The next tier of people who look at that are the maintenance team. And if they can't figure it out, then it goes to the core development team. And so I walked that ladder from support and then finally all the way to, I moved here when I joined the maintenance team. And then the team whose code I was maintaining hired me to be a full-time developer. And so I think that was probably the most traditional distributed systems development role that most people would think about. We did some interesting stuff there, but I learned a lot over that journey about how I would and wouldn't approach software development, how I would and wouldn't think about who owns what and who's accountable for which part of things. For example, like I don't agree with an external QA team. I think that's bad. I don't agree with the concept of a DevOps team. I think that's bad. I don't agree with the concept of like a maintenance team. It just doesn't make any sense. The incentives are not aligned. You're not really setting yourselves up from a human perspective of good outcomes. If I can produce crappy code and it's someone else's job to figure out it's crap and it's someone else's job to fix it, then what is driving me to improve my practice overall? So it was very formative to my experience as a software engineer. And I sort of figured out like, oh, okay, here's what goes wrong if you approach it different ways. And I wanted to be really good at it. So anyways.
That's actually good, if I may interject a question here, because there's a lot of good stuff that you just said, and you have very strong opinions about this. It's very relevant because I was just having a conversation about this very thing, bringing in a almost unbiased party to evaluate the quality of the code that the developers are writing. Is this valuable? Is this not valuable? Maybe we should start with that. Like maintenance team aside, do you think it's valuable if the developer writes code to have someone who's not necessarily familiar with the way that the code works be testing it, right? Looking for happy path, but also the not so happy path, right? The abuse cases or anything that they can think of that the developer maybe didn't think of, or even the product manager didn't think of when they were originally designing it. So what are your thoughts about that?
I think one, engineering owns test. And any engineering organization that claims they're doing test had better be also making sure that the things you just said happen. They're not doing test if they're not. How you're describing a search space problem. And so the question I would have is, how do you know you're doing a good job of establishing the search space for tests? How do you know you've done a complete job of defining all of the positive and negative scenarios? And so I'm going to argue you have to do all those things. But what I'm arguing is that the engineering team needs to own it, in the sense that they have to feel the pain when the test fails. It can't be that some other team, which is a pattern I've seen, is where their engineering teams don't own test. They don't even necessarily write tests. Someone else writes the tests. For example, you may do no unit testing whatsoever. And there is another team who exhibits all of the good values that you just described, but they write the integration tests. And when it's broken or when it's whatever, hard, it's just they need to solve that problem. It's never the developer who has to solve that problem. I think that type of approach doesn't make sense to me. I don't think it aligns incentives. But I do think what you said is true. Like, you're not doing test if you're not being rigorous about how you set the search space and how you know how complete it is. I'm not talking about code coverage. You know what I mean? That's something else. I'm talking about like functionality coverage. And I think that's very important. Yeah.
Yes. Which would maybe include non-functional requirements there too.
Right. Exactly.
I'm
assuming.
Yeah. Okay. So what does that mean in terms of an org structure then? Like, what is it, you say engineering should own tests, but does that mean someone on the same team, like Scrum team? Would you go that far? Or is it like there's a separate QA group that maybe they're loaning QA folks out, right, to the various development teams? What does that look like in your mind?
I don't know if I would torture it, Dustin. I would say everyone knows what it looks like when incentives aren't aligned. And that's when someone is suffering more than the person who created the problem. So at any time, if the problem started here and there's a disproportionate amount of suffering along the chain, you're messed up. And that's all I can tell you is like, I don't know, you figure out your org structure. I don't think it's that hard. But like, I think, yes, probably within a team who has an overall incentive to ship a high quality product. Let's imagine that exists in the first place, but like, okay, like probably a decent place to start is within the team. But, we can talk about this more in other contexts. Like you can stick someone in a team who does test. Does that mean the developer's not just going to treat them poorly and not give them any feedback? You know what I mean? Like, it doesn't prevent any of this perverse non-incentive stuff from happening. So it has to be not only that the team is in a way that it's small enough and everybody has the same incentive, but like, it's kind of like democracy. You gotta have, which think about that what you will at this moment, but like, you got to have like checks and balances, and everybody needs to share in the suffering. If you don't suffer, then you don't improve. And so when I look for it, I look for disproportionate suffering with people who don't have agency. Like, where there's suffering, there needs to be agency. And if there's suffering without agency, then that's bad.
Gotcha. Okay, that makes sense. And then the other piece of that is the maintenance side, handing off to some other group to take care of maintenance. Yeah. Share your thoughts there too. I have my own opinions about that, which align with yours. But if you could share some of where your beliefs come from and sort of what you've seen firsthand, that might be really useful.
Well, I think it's the exact same problem, which is the person who writes the code is not disincentivized from writing buggy code. So first, this is all part of one continuum, and everyone is a casualty. These are all people who are suffering with no agency. So the person with all the agency is the developer. That's the person who writes and fixes the bug. They first produce a defect. And if it comes to test, and hopefully the test scenarios were defined completely and the defect is captured at that point. But now the person who found the defect has to write the reproduction steps. They have to make sure the repro is all good. They have to gather up all the data. They got to bundle this thing up, and they got to put it in a ticket, and they got to send it to the dev. And so there is all of the bundling and then the potential clarification and the back and forth. Developer thinks, I don't want to work on this today, I'm busy, I'm just going to stonewall this person, right? The test person has no agency. They're blocked. They're blocked because they can't affect the code. They have no agency. They have now suffered. They're suffering and they have no recourse. So that sucks. Now, let's imagine for a minute that they missed it in the test. The developer wrote the bug because that's what developers do, myself included. We write bugs. And then the bugs make it past test and they make it into production. And now the customer was the one who discovered the bug. And they say, you wrote a bug, you suck. And we spend a bunch of money on support, pumping it through another code apparatus with more bugs that says, we think the bug's over here. So a bunch of people have suffered because they've spent all this time trying to debug this thing, and they don't know what they're looking at because it's like counters and metrics that some developer wrote. The guy who wrote the code knows what counters he put in there or she put in there. Like, we don't know. And so we got to go on this archaeological expedition to figure that out. Suffering with no agency. So anyways, so then finally it gets to a maintainer after everyone has suffered and barely has a clue like what's going on here. They hand it to some maintainer and they say, God, these guys have no idea what's going on. None of this is relevant at all. The bug's actually over here. They take a look at that, but then they hand it to the developer, and the developer says, no, you're all wrong. Actually, the bug's over here. You guys don't understand how the code works. I'm going to do the fix over here. You guys are useless. That's the doom loop that you're in when you have that type of thing. And I don't think it has to work that way, but I think, well, if you live on planet Earth in this universe and you use humans that also exist here, and you have over 1,000 employees, there's a version of that playing out somewhere in your organization, just because the incentives aren't aligned. Like, a developer shouldn't be able to get out of bed in the morning because he's so miserable from all of the stuff he has to do or she has to do because of the defects they've introduced in the code. But instead, you just do this other stuff. So
I've been involved in so many conversations around process changes, like fixing the pain that you're describing. So I'm glad you were able to expand on that a little bit for us. I can start to see. Yeah, go ahead.
Sorry, I just want to interject one thing, which is okay, this is not to just seagull crap directly on developers and why. Okay, there's a more basic thing, which is because their boss keeps telling them to ship features. And so when developer wakes up and thinks, how do I get another paycheck today? They think I have to write another feature, and testing it and worrying about this other stuff is in the way of me writing another feature. So sure, they should have better professional judgment and whatever. We can talk about their agency, probably not for today, but okay, there's a bigger machine, there's business, and business has a profit motive. And so it's hard for lots of people. And sometimes you'll find an org where you don't overcome profit motive. but most people just don't make any noise. So anyway, yeah.
I like what you said there. Most people don't make any noise or enough noise. That's something that I always pushed people to do, is share what's painful, especially on the engineering side, instead of just taking it. And I've sort of seen that as a rampant issue. But what I love about what we just talked about is I think certainly I can start to see how all of this background of yours started to shape your approach to AppSec. We've already sort of touched on some of that, but let's continue with your journey. We were talking about
it's a good segue. Yeah,
it is a good segue because next.
Now I'm in the Bay Area. Right now I'm in the Bay Area, and because I'm a diverse individual with lots of good hacker buddies living all across the world. Now I'm a software engineer. Right? Surprise. Me too. But I'm at Citrix, and I'm doing pretty good. Principal software engineer. Like, I get paid enough money. Like, I'm good. But I'm like, I've been here 10 years. Like, what am I doing? Like, I came to Citrix to come to Silicon Valley, to leave Citrix to do something else, because, like, God bless Citrix. What a great outcome for me. But, like, finally, you don't move across the country, if you're me, to stop there. And maybe that's like another problem in my life. Problem, whatever. Is like, well, it's never good enough. I'm always trying to can I climb one more piece higher? I didn't go. It's important lesson. Like, I didn't go to college. I see a lot of people talking about a lot of stuff. I just like to figure stuff out, man. And the more I figure it out, the more I like doing it. And so anyway, we'll come back to that, because I'll tell you where I got to the top of the ladder and decided to go back down. Maybe not the top, but anyways. So I'm here in the Bay Area. A buddy of mine is here. He's a CISO at a healthcare startup. He knows that I've done all this other stuff. He calls me up and says, hey, I'm trying to start an AppSec program. He's like, I think you know about software engineering. He's like, I know you know about exploitation and other stuff. Like, I'm sure you can figure this out. And I was like, oh, you know what's cool about that is, like, for my entire career, I've been saying, oh man, I wish I want to be working in security, but I'm already doing all right. Like, I'm not going to go sit in a SOC and look at alerts. Like, no, that ain't for me. So he says, like, hey, why don't you just come start this AppSec program? And I was like, oh, okay. I hadn't really thought about that, at all, as a matter of fact, because, like, AppSec at Citrix, like, I won't go into detail, but let's say there was people trying to do hard work, but as developers, we were not listening. So I'll just say, like, I didn't learn anything about how I wanted to do that part of it there. But I realized, like, okay, my approach in life. So suffice it to say, I took the job, which was crazy. But, like, my wife is a great person, and she's always like, hey, whatever crazy thing you're thinking about doing, let's do that. Just do that. You'll have more fun. So anyways, I did that. I joined him, and because I like to think I'm a disciplined thinker, I thought, okay, like, what does it mean to be good at AppSec? Like, what is that? So I just said, hey, leave me alone for a minute. Like, I'm just going to go read everything there is to know about this. Let me go do, like, a meta-analysis of AppSec, because, like, I know how to find information. I've been on the internet. So I kind of did that. And, like, at that time, security champions was a pretty new concept. Secure defaults was not something people were really talking about. I'm trying to think, like, what year is this? It'll come to me at some point, because, like, Snowflake was 2018. So, like, 2010s, late 2010s, somewhere around there, whatever. But, like, this idea of, security team is the team of no, and how will we solve that? And security champions will be it, right? We'll get these volunteers and we'll deputize them, and we'll teach developers about threat modeling and stuff like that. Like, it was beginning days of that. And people were just starting to talk about stuff like Gherkin and, like, using behavior-driven development as a way to do threat modeling. So, like, there's some early thoughts about how to embed it, and then two, even how to try to express it as code. And so what was cool about those things is I was like, oh, you're talking about tests. You're talking about tests that I believe developers should be writing. I don't know why you're talking about writing them, but, like, you should be telling developers they need to write tests. And so anyway, so we got a chance to play with some of this early stuff at Collective Health. I'm not going to say super successfully, but, like, I read a bunch of stuff, and then we tried it. We tried security champions. We tried teaching developers threat modeling. But I don't know. I would say all experiments need to fail a couple of times. So law of numbers says one of them had to fail anyway. But if I look back, I'm like, well, we didn't have enough experience yet. Like, we pulled out Threat Dragon. We tried to teach Threat Dragon to developers. we didn't really think about like harder problems. Like you got to have a community, you got to incentivize them, you got to learn. So lots of obvious things that are now written lots about in hindsight. But I guess the big thing I came away with when I was at that place was I was like, God, everyone wrote this thing about you should do X, but no one has written about what happens after you did it. And so I decided that like, well, that's what I'm going to do because I don't have a better idea. I think there's a bunch of smart people out there writing about this. I think I read about them on the internet, and I think I read it like 5 or 6 times. And at that point, I'm like, okay, there's some consensus here. You know what I mean? And I'm like, oh, this resonates with me as a software engineer because I hear you talking in software engineering terms, even though you may not be directly using them. You're talking about writing tests. You're talking about negative test plans. You're talking about these. You're talking about embedding the culture. Oh, that makes sense. That's how we scale it. Like, okay, sure. Like I see the pieces now. As an engineer, I'm like putting together this system, and I even see some ways that we can map security terms to engineering domain terms. I'm like, okay, let's talk about testing and these kinds. So whatever. We did that at Collective Health. We were there for 2 years, but like all good startups have some dysfunction. And so leadership disagreements, whatever. We decided to part ways. So I had one failed experiment under my belt. And then, I went to a recruiter. They mentioned 2 companies I'd never heard of. One of them, which was Snowflake. I meet a really smart guy, founding architect named Peter in the interview. Super smart. Just clicked with him immediately. We had a good long conversation. So that was cool. Then I met, my future boss, Mario Duarte, who was a CISO. Pretty cool. He had actually seen a video of me on YouTube crashing my bike and mentioned it to me without me mentioning it to him. So that was weird signals from the universe that like, it's strange. Anyway, we're both cyclists. So anyway, it was another just weird thing about Snowflake, but so anyways, I took the job. So Snowflake was like, hey, be a cloud security architect. And I was like, I don't even know what that is. But sure, like we'll all figure out what that means. Seems like you guys are asking me about AWS and some other stuff. And like, I'm pretty sure I'll figure out what it is. So I get there. There's Peter reviewing everything, right? Like brilliant, genius, great. And I'm like, but then Peter's like, all right, I'm going to leave in 2 weeks. Very classic startup move, by the way. And so I'm like, oh man, that's a bummer. Not only would I love to learn from you, which I learned from him, and I learned many invaluable things. So no love lost there. Like this is just life. It just shifted my perspective on what needed to get done in that role at that time, right? Like at the time, there were 2 people. One of them was already doing security reviews of software, and one of them needed to start thinking about cloud. But in reality, what was happening is that 2 would go in, but 1 would come out. And so that meant that I was immediately like now the guy, the bottleneck at Snowflake. Immediately, people are like, my calendar is filled with meetings, and people are like, review this dangerous feature you've never heard of in a database system you barely understand. And so that was the very beginning of my role at Snowflake, which was just like the water hose of, hey, Peter said you're reviewing the features now.
Oh my gosh. The bait and switch, right?
Kind of. I mean, like everybody's got to do their thing with their life. And you know what I mean? It's whatever. There's none of that. But it just, things always change. Nothing is ever easy. Statement of my life. Nothing is ever easy. Anyways, but the point is that at that point, like I had to say both to other people and to myself, like, okay, we don't need a cloud security architect. We'll figure out what that is later. Like what we need is an AppSec program. We need like a software security. So first, Dustin, like I don't get the difference between app and cloud, especially at Snowflake. Like especially in that product, it's the same thing. Okay, the cloud infrastructure it depends on is so tightly coupled to the software that runs on it. It's like you're making me tired trying to distinguish between the two. So I'm just like, it's product security. We first called ourselves cloud and application security, which makes me want to throw up. It's so many words and it's so annoying. But finally, the way we came to think about it, and it has to do with how Snowflake grew into an IPO, was to IPO, we needed to have a corporate muscle. Like you have to do HR good and you have to do other things good. And so like you now need to not think of yourself as we're a scrappy product company. You have to like now build IT and all those other things. And so the main thing we thought selfishly, whatever it was, it just showed our bias, like product is over here. And then this corporate thing, we have to figure out how to do that because we're all a bunch of database engineers and product database people. Like we don't know how to think about that. So we got to hire people to do that. And so when we looked at the security org, we said, well, we're having a hard time from product telling corporate, like, how to operate and what, like, now the influence is harder. So we need to be a security org that is responsive to the organization. So we said, what could we do? Oh, well, we could divide ourselves into 3 pieces. How about that? One piece will be focused on the product. One piece will be focused on the corporate. And one piece will be the one ring to rule them all, global security, which basically makes sure like, hey, we're actually uncomfortable with breaking up and we know that we have to secure all of Snowflake, but to influence our respective organizations, we have to be inside of them. And so we are going to create this triangle. Each of us will be anchored, to the triangle. Like it's always that triad who makes the decisions. But suffice it to say, like, that's how we made sure that we both had autonomy in an org and allowed the orgs to make the decisions they needed to move as fast as they needed to. But that finally, that triangle was accountable to the board for risk. And we shared the same list of risks across the whole business. And then we managed that together. And so that actually kind of even gets into like more now the leadership part of the role. But right, like technically we grew up, like we realized we needed an AppSec program. I started working on that. 2 of us were working on that. So that meant like we put a pause on reviews and there was a lot of suffering and gnashing of teeth. We rolled out revamped security review with security partners. We didn't call them champions. So here's where some of my opinions came in. I said, that's champion thing, volunteer, no good. Like developers need to have a stake in this thing, but can't ask developers to do too much. So we'll just ask them to do the developer part of this, which is like, hey, can't you diagram your design? Hey, can't you write tests for it? Like, hey, can't you think about some lightweight security kind of tests that might be relevant? I'm like, it's calling it security is almost a red herring. It's like, just complete your test plan, dude. Like you're not thinking about this area of functionality and you're not doing it right. So one is we wanted to make it lightweight. And then the second thing was we wanted to say like, okay, we don't want someone's job to review someone else's security. So instead we want them to create a deliverable and then they peer review the deliverable with someone else. But that someone else is not a security person. That someone else is another developer on the team. Because what do developers already do? They write changes, they put them in pull requests, and they get them peer reviewed. And so we just thought like, okay, great. What you're going to produce from our process is basically a series of test scenarios. You're going to get those peer reviewed. And that's going to be, or a risk assessment that says, I don't need to do that other step. There's 2 outcomes. You peer review the risk assessment deliverable and you peer review the security requirements deliverable. Now, the magic we invented was how do you automate the creation of the security requirements deliverable? Or how do you make it super easy for the developer to get through the threat modeling process or whatever you want to, you don't really care. It's a magic box that understands the design and spits out relevant security requirements on the other side. And so it's like, hey, that's what we're looking for. Either you risk assessed and said, no new requirements, all requirements are met, and you had evidence of that. Or you said, whoopsie, there's no requirements. So I created these new ones. Here's how I know they're good. And here's how I show you I met them. And those were kind of the 2 basic deliverables. So I'll pause there.
Was that a manual process then, or more of an automated process? Okay.
God bless it.
So you had like a form to fill out or something. Like what did that look like in terms of?
It's better than that, Dustin, because I'm a real. I guess it makes me. Which one is it? I think it's the one that inflicts the pain. Anyway, so for me, I was like, what we don't want to do. Like I had already imagined it would be automated. I am already imagined that it would be as code. I knew that like I didn't have all the answers to that. So what could I do? I said, well, okay, I can parse Markdown. Like if I put Markdown into sections, I can at least like parse a doc at scale. So that was the first thing. And then I was like, and then what's nice about that is, let me back up. I said, I want this to live next to the code. The first problem is, where does the deliverable live? That's actually what informed the rest of this. I said, it cannot be in Confluence. It cannot be on a whiteboard. No one cares about that stuff. I don't have to say more about that. Nobody cares. The only thing they care about is the code in the repo. They kind of care about the tests, but the tests are code in the repo. That's actually the stuff they care about the least. But at least it's on the radar. Like someone might look in the test folder. And if you talk to a developer about like, did you do this? You would at least be on the same planet as them when you're like, did that test pass? Is that test defined and is it in the repo? You know what I mean? And you might say, hey, I see that this test is aged out. Anyway, you could imagine talking to them about tests. You could hardly imagine talking to them about, did you update Confluence? Did you update the whiteboard? Never going to happen. So the first thing, we wanted it to be in source. We wanted it to be in the repo, and we wanted it to live proximate to the code it was relevant to. Like, at least with a test file, it doesn't physically, but like you can find which piece of code it's testing because you called it. You called that piece of you've called that function by name. So we're trying to get there. So what we knew was like, well, it's a markdown with Gherkin inside of it. Now, it's not as good as a test file. It's more like one giant test file with the scenarios defined inside of it. But at least we can start to think about, I can parse that. I can parse the scenarios out. I could add metadata to those scenarios, which are like, which piece of the code does it? So it's just a very bare skeleton. So without torturing this too much, I just thought I got to have some data structure. And this is good enough. And the super benefit of this is they can just type this in GitHub directly. No big deal. Like everybody, the barrier to produce Markdown was actually lower than you might think. People were pretty happy to produce Markdown. They knew what READMEs were. We made it a nice form. We ultimately like put web UIs in front of it, but we actually still produced Markdown for a while. It didn't really matter. But okay. So it was Markdown and it was checked in. It was source controlled. And through that source control was where the peer review happened. We had a whole system of peer review and meta peer review to make sure everything was good. But like, that was the machine. You made the Markdown in GitHub, in this repo. It was correlated to the work that you were doing. It went through peer review. It got merged. And that's how we knew you were in compliance. And we knew that we could go do independent validation or whatever it is we wanted to do after that.
Got it. Yeah, no, that makes a lot of sense. I want to go back to something you touched on earlier, which is really what I would say is security starts with good engineering practices. So you talked about having developers do what they do as a way to push your security program forward, create those architecture diagrams, etc. I completely believe in that. And when I talk about security champions, I talk about having people be responsible for those types of things. I talk about it in terms of contributing uniquely from where they're coming from to help the security program move forward, which essentially is a very similar concept, right? Do the things that are going to help you as an engineering team, but also turn around and help the security team as well move forward. So I'm glad that you mentioned that. Okay. So how did it go? So you're putting all these pieces in place at Snowflake. Just so results, did this work? Did this not result? Or did this not work? And what else did you sort of try while you were there?
Yeah. So so first, what worked really well was decentralizing security review. So when we went from 2 people and we said, actually, we're going to put the brakes on everything, the suffering reached its peak because we were delaying features the most. And then it broke when we said, here's a new paradigm. Here's a new paradigm. Here's how the whole incentive model was. You have the power. If you're blocked, it's your fault. And here's the tools to unblock yourself. And here's how you understand that it's a process you have to customize. If you fail to customize it, it'll be painful. It'll go slow. So don't come and tell us it's painful and slow. That's expected. Here are the tools to customize each part of the process. Here's how you should think about capturing the value from your pain so that next time, the big mantra was every threat model is a failure. You never threat model something twice. So we tried to give these teams, we didn't try, we gave them. Did we succeed? Did they adopt it? That's another question that I'll come to. But we described these value loops because we knew we wanted to be able to come from a customer value. Why do you care about this? Because you're complaining to me that it takes too long to ship and that I'm in your way. I will not be in your way. It will not, you know what I mean? I'm not going to substantially raise the burden on you. I'm giving you now all the tools you need when you say you don't want to talk. I'm giving you what you want in some sense. I'm giving you I'm giving you everything you need to customize this process to go faster. The tax is that you have to engage with the process. It's not optimized for your team already. Your team will have to pay. You will have to engage with it heavily up front. So this is a problem, Dustin. You cannot, if you go into it's I'm just going to fast forward because it's all present. Red alert. If you're going to tell the team you have to set aside extra time to figure out how to level this up, it probably won't work. At that time, I'm like, what do you mean that won't work? I'm just telling them the risk assessment today only has 3 items on it. If you go to that risk assessment and there's a 4 and you're like, F this thing, why doesn't it have item 4? Simple. There's a PR right here. Type item 4, put it in the risk assessment. Here's the peer review. Within an hour, it will be updated. Nope, I'm sorry. People will just say, "Why? Where the F is number 4?" And they will not go do the peer review. They will not add number 4 to the list, and they will just be upset. Now, there's some small percentage of teams who will be enlightened thinkers, maybe more wrinkled brains that will think, "Oh, this is good for me. I can see why this sucks. I can see that they're trying to do okay." And so you could it's direct correlation. You give them the package, you look over time, and you can just count the number. The single biggest predictor of how successful a team was the number of items in their risk assessment list. Easy. If they didn't customize the risk assessment, they were definitely not doing a good job of security review. So anyways, some subtle things like that. But we felt like we had this really enlightened system that was really power to the people, putting all the power in their hands and giving them all the incentives. And so that's how we set it up. And what I'll say is it did kind of work. Some people in a large system are always going to be chaotic and not adhere. And whatever, we had other systems that we put on top. Manual audit. We sampled the percentage of stuff. And surprise, the amount of stuff we caught went up, in some cases instead of down. But ultimately, it worked until it took us a while to realize it wasn't working. But it worked until 500 developers. You're really depending a lot on the goodness of the developer. I'll tell you what the root of the problem is, Dustin. We were asking them to threat model. And the way that we asked them to threat model was come to our tool, draw the diagram for me. I have this really clever way, even if you just draw the diagram, I'll even give you the threats. Magically, I'll give you the threats, but you got to come in there. And if you just do that, I will produce this test plan deliverable for you. I'll create it for you. I'll even check it into your repo for you. I'll start the peer review for you. You just come in and draw me a diagram. This actually worked, man. Because it was dead simple to do it, and it would spit out this 80-20 type of threat model. But it backfired in a couple of ways. One, most people, so the idea was, if you draw me the diagram, I can tell you 80% of relevant threats. You just need to make sure they're relevant, but then you need to think about the extra 20%. Okay, newsflash, they will neither confirm the 80% nor think about the extra 20%. They will just be like, sweet, looks like I got the deliverable, submit. That's so the problem was we made it too easy to get through the process. It defeated the critical thinking aspect of things. What we paid a high mental tax for before with that manual deliverable had this really nice benefit of you kind of had to explain it to somebody, and it forced you to think critically through it. When we automated that process, it took the critical thinking out of it, and that was bad. Then the second piece was, for the not simple stuff, stride-based threat modeling is hot garbage, man. I'm sorry. After a certain complexity, it just doesn't, the developers can't figure out how to express themselves using that language. Finally, the language of stride and that awkward mapping, the tax the developer pays to think about, I've understood my system like this, any normal person would understand it. And now you're forcing me, either through this slick UI or through some other means, to describe it using these grotesque stride scenarios that are from 1964. And it just repudiation. Who says that? No one even says that word. So you're automatically just, you ever watch What We Do in the Shadows? It's a show.
Seen that. No.
But anyway, check it out. It's very funny. It's comedy about vampires, but some of them are real vampires, but one of them is an energy vampire. And all he does is show up in corporate settings and ask these really draining, obnoxious questions, and that's how he feeds on people. And so I just feel like this is one of these energy vampire scenarios is where they're just oh my God, why are you making me talk about normal developer stuff with stride threats? I did. And then if you go read ASVS, it's that's sleeping material for developers, I feel. So anyways, So I feel, and I presented this in the very talk that you mentioned here, the shift left sucks for SWEs. Yeah, it does. I felt like we created this torture box in the end where it's I put all this stuff in front of you, and I keep forcing you to understand more and more about security, because at a minimum, you're trying to understand stride. But then for us, I'm not going to try to say Snowflake was special, but the features were hard and dangerous and dealt with sandbox code execution and putting that in one account and then marketing that in a marketplace and monetizing it in someone else's account with privileges and all kinds of crazy stuff. So it's Stride is not that helpful. And so we were trying to teach, and we asked them to know too much. Like, finally, the volume is so big, the complexity of the features is so high, there's so many people working on complex features that, like, this threat modeling thing that turns off the critical thinking part of your brain is now like a poison pill, in the sense that, like, it just made everybody dumber, I think. I shouldn't say that, because I have like I tend to look back on history harshly so that I have a strong base on which to proceed forward. You know what I mean? But I feel like in the end, I'm like, gross. But what changed my mind about this whole thing and really made me see, like, there's got to be a better way. Not only all this suffering and, like, human interfacing and trying to make these complex human systems interact well with each other. Snowflake acquires a company called Applica. Applica is a document AI company. It reads your PDFs and it says, this is what's in your PDF. Like, this is right before ChatGPT, I think, was really being discussed heavily, before I really understood anything about LLMs. I understood a lot about data. I understood from our AppSec system, we were actually benefiting from extracting data about that system. Like, we didn't talk about this, but each time they drew that diagram for us, we didn't throw that away. We saved that. We saved that in a database as a graph. And when we put that, the first thing we did in the database with that graph was we queried it for stride threats. Okay, and there's a set of rules you can apply. You can model it as a graph. You can store it in a graph database, or even in a flat database as nodes and edges, and you can just run these queries. But what it meant is that every time a developer checked one of these things in, we got a snapshot of nodes and edges, and we stored them in a database. And so you could start to solve another problem, which was, how do I crowdsource who understands Snowflake? It's so effing complex. No one understands it. There was not that much documentation. Like, we wanted to get our hands around the system, and we saw big brain thinking here. Okay, we're going to try to get it for free from all these developers. And so that was like a very basic semi-structured semi-structured data extraction task, right? We had semi-structured data in Snowflake as Markdown first, and then as JSON later. And then we were just extracting out of that and then doing other analysis on it, forming a structured data, which was a graph representation of that system. So there were lots of ideas and things we could do with that. But suffice it to say, LLMs come out, and we think, at the same time, Snowflake is getting pretty good. We're writing 6-pagers. Most features have 6-pagers. There's a lot written. So anyways, document AI comes to the scene, and we're immediately thinking, couldn't we just rather than having the developers come to the portal and draw the diagram, like, couldn't we just extract the diagram from the document? Like, couldn't we just read the document and suggest them the diagram and say, I think this is what you were talking about. Is that right? And then, like, if we did that, could you keep that tightly coupled? Like, if they said no, could we fix the document for them? And could we now just have, like, imagine like a hologram or something? It's just a temporary projection that says, I've understood what you said to look like this. You see, the API we defined was a data flow diagram. So, and all we're talking about is the price you pay to generate a data flow diagram. All of this friction, you got to use my UI to create a DFD that we both look at and say, that's a DFD. So I would just shift it all the way to the document and say, I could just get the DFD now and forever, and I could even update it forever continuously. And we would both be looking at the same DFD forever all the time. I would solve that one part of the problem. And then I could build upon that. So, like, that was sort of the premise, is like, if we could read the documents for free and at scale, then we could shorten this process even more. So that was pretty important to how I started to think about why it's a data problem rather than like teach developer be good at security problem, which was, I was like a religious zealot on that thing. I was like, oh no, it's teach developer do less, but secure default, no good. It's like, it's not that it's bad, but like, I think a lot of people talk about that like it's easy to adopt, and it's not easy to adopt. Like, you can just have code that's dangerous, and like, security team is not going to magically make that a better API. Like, you need a lot of engineering muscle. What I would say is, if you're going to build like really bespoke stuff, which was what we did there, and have it be like a good API to begin with, is already an effort, much less like an API that is like totally secure from any kind of, like, we were long game invested in that. But what I'll tell you is, like, you better be long game invested if that's what you think you're going to get. And you better be in that engineering org, you better be hiring software engineers. You better be hiring ones that are credible in delivering this stuff. Like, you have no idea what you need to do. You're not doing that with a team of security engineers, and like, stop kidding yourself. So beyond that, there's lots of things you can do, secure defaults, but like, it's hard to get real influence at scale unless you're really deeply hooked into the engineering practice.
Yeah, I think I'd agree with that for the most part. I've had trouble. I've always had these like dreams and visions to get to that point, right, where we've got secure defaults because we've got common libraries, et cetera, that we've written as a security team. But there's so much respect almost that you have to earn as an
it's not built here, man. Right.
You know what I mean? Like, you're not in the engineering organization, so why would they respect your software engineering qualities? You're just the security team. And I think a lot of that causes enough friction that, you know, the hope that would work is just so far off in so many companies that I wouldn't even start there, or I wouldn't even be thinking that. It's just like, figure something else out, because it's not going to work that way.
There's definitely a human problem that still shows up there. And so like, great. I think people need to be cognizant of that. And it's exactly what you said. Like, okay, you want to play, that's not checkers. That's not chess. You know what I mean? It's 4D chess, whatever it is. Like, you really got to be thinking long game if you want to do that, because right, a lot of orgs, like, who are you? You're not in product.
Exactly.
You're not even if you're in product, you got to think about yourself. You got to be self-critical as a security team. Like, are we production level software engineers? Like, it's fun to think that way. I certainly thought about myself that way, but like, well, there's a difference. Like, you shouldn't minimize. Totally difference. You shouldn't minimize. Either role can't be minimized. Let's put it that way.
Exactly. And then going back to our earlier conversation around QA testing and all that too, you have to be mature in terms of your process for producing that software.
That's right.
Then you're signing up for maintenance too, ideally. You're not going to have the development team or the engineers also maintain, you know, what you've built. You have to take ownership for that too. You build it, you own it.
Right.
So there's so many reasons why that would be a very difficult path to go down. Like, we are rocking this. This is an amazing conversation, and I'm glad that you're sort of sharing all these details, et cetera. I do want to talk about sort of post-Snowflake, because you're not there anymore.
Yeah.
And what have you been doing? What did you do afterward? What are you doing now?
So, I mean, when I left, I was thinking about a lot of these things. I essentially decided that this whole thing is an information extraction problem, and that the state of the art, like the inflection. So one, I'll go back to what you said. Like, I don't know that there's a security problem here. There's a software engineering problem here with a slight security side effect. And like, I think that I'm going to throw up after I say this, but like, you know, there's a technology inflection in LLMs that has, I'm going to say the word revolutionized, because I believe that in a lot of senses, natural language processing. And a lot of the stuff that you and I just got done talking about, language text, these are NLP problems. Like, it's brain dead, stupid stuff. There's not any real reasoning happening there. It's just domain terms translation. So I became highly convinced that, like, okay, when I want to make it easy for developers, and I'm not just talking about secure defaults, like what I'm really talking about is, are we good on requirements? Like, did we say what we wanted to do, and did we do what we said through each step of the SDLC? And if you had a handle on all of the, the fuzzy information loss requirements to design to whatever, if you could really just co-pilot that process for a developer, you'd be in good shape. And like, guess what? Look at what happened over the last 3 to 4 years. Like, I guess I was right. I mean, I wasn't the only one thinking that by any means. Clearly, everyone was thinking that. So like, great, developer co-pilot revolution. And I'm like, yeah, that's what we need. But I mean, I guess there's nuances to how I think you should approach that. And I saw companies coming out in the security space and how they were approaching it. And I guess, I had some thoughts, because I started to educate myself in this space, and like, how do you think about NLP, and what do people do with that, and how do you make sure it's really right, and things like that. And I guess I didn't agree with what other people were doing, so I thought there's a better way to do it. And so I went off after Snowflake, having already discussed it many times with some good friends of mine that we wanted to do a security venture together. We all left. A couple of us left Snowflake, and another one left his place, and we got together and started exploring security ideas. But ironically, we immediately disqualified this AppSec idea, because we said, you know what, nobody pays for secure software design. Like, when you go talk to a lot of customers, like, they're just like, what do you mean? Like, I'm not threat modeling anything, and I don't care. Now, when I look back I see a lot of companies emerging. I'm like, you can get money in this space, and I guess somebody's paying for it. So like, should we have pursued it? Whatever. I don't really. It's neither here nor there for me. But like, I just didn't have a strong belief that secure design was going to be like an explosive, growing VC investable business. Like, I didn't see the market there, and I just didn't see the appetite for customers. So we were looking at other things. So we explored a couple of different ideas. And I guess if I were to really just kind of say, what did I learn? It's like, you can have a lot of good ideas, but you gotta think about what you're trying to do. So, you can go out and try to solve some problem for the world, whatever. That's one goal, and that's fine. Another goal is to have a successful business that's VC investable and experiences growth and has a profitable exit for everybody involved, right? Like, okay, that's a fine goal as well. But those are two very different things. And the number of opportunities and the constraints that you would think about for one are very different than the other. And so what I'll say is, total addressable market rules everything. And in security, one, not only is it crowded, but having an idea that really applies, having worked in a place like Snowflake, which is very much kind of a 1%, you can solve lots of 1% problems. How do you make a really successful business on a 1% problem is not that easy. I'll say that. And so ultimately we did not find an idea that we felt like was bigger than 1%, but I was still not done. Like, I could say a lot more, but I'll just say I kind of decided I thought being in Silicon Valley is not about becoming like necessarily staying in the senior director and doing all that stuff. Like, I enjoyed that experience and I got to learn a lot of stuff, but I really like to solve problems. And it turns out like I can solve people problems and I can solve any problem, but I don't get out of bed thinking like, I want to tweak an organization today. Like, I want to optimize my org structure today. And the fact is I met people who did. I met people that I respect that said like they wake up and they think about that. And so I just think you have to be honest with yourself. It's like, do I think I could be 99% as good as you, 95% as good as you? Like, yes, if I I could. But the fact is that I said it at the very beginning of the call. If I'm not motivated, I'm not in it. And so, initially the newness of this problem of managing people was super exciting to me because I'd never done it before. But once I kind of did it, I realized, look, this thing doesn't necessarily, especially large team management. Like, I don't know, is it playing to every strength that I have? I think no. Like, I learned a lot at Snowflake. I learned a lot of things I would do differently. The question I asked myself was, okay, Jacob, you've win or learn is kind of the thing. So we did a learn. What are we going to do next? Do I want to go learn and grow as a leader, or do I want to, as a leader of large teams, or do I want to grow and learn as a leader of solving problems? And I felt like that latter part was much more exciting to me. Like, I hadn't done that before either, and maybe it's going to wear off and maybe I'm just a nerd, but whatever. Like, that's really how I sort of bifurcated and sort of decided like, no, I wanted to do a startup with my friends because I just want to work on cool stuff with people I'm cool with. And like, I want to work on something hard. And then there became a question of like, okay, well, do I want to go back now that that's not going to happen? Do I want to go back into the leadership world and do that? And, I entertained it and I had some great, interesting conversations, but finally another opportunity came across my door, which was continue the startup thing in maybe an adjacent area. And again, I'm not going to say too much about it. And you and I have talked about that, but like, if I said that TAM was the most important thing, then what I would be looking for in my next startup was a real big TAM. And so I'll just say, it just so happens that a lot of the ideas are the same and the TAM is much larger. And I wanted to, work on a hard problem with a small team and try to figure this stuff out. Like, I'm really passionate. I hate saying that. I'm super interested, dude. The number of papers I read on LLMs and this whole space, like, I just spend a lot of time there. And so I just know that that's something I really like to do. And so here we go. Like, I got to focus on that. And we're still doing a high stakes startup situation. So like, good. And I know all these people. I've worked with them all before. So it's all there. So I'm like, hey, let me keep running on this. Like, I don't have to give up. And whatever we do here will necessarily be one step further toward whatever future. Like, if we try to pursue another product again as a team in the future, I just sort of look at this as like, it's all gravy. You know what I mean?
That is awesome. I actually wrote this down to dig into a little bit more. Unfortunately, we're going to run out of time here, but I like how you follow, I'm not going to say passion, but you follow what motivates you. And you sort of read that, and you seem very in tune with how you respond. It's almost like you're an outside observer of yourself, seeing how you respond to certain things and then using that to guide yourself right into the right place. Yeah. I think that is very wise. I see a lot of people just ladder climbing, because it's the next thing and they're really not that interested, but there's more money involved, or it's the next, step on the ladder. And I think, they turn around years later and they're like, I don't know how I got here. I'm not happy. I made a series of decisions that were not based on what motivates me, but just sort of doing the next thing. And I think that causes a lot of problems for people. So I think that's really what motivated me to reach out and have this conversation is that, I'm fascinated by that, and your journey is very unique. And I think that's awesome that you shared all of that with us. So, I think this is probably a good time to end the conversation. I really enjoyed it. Again, thank you for being here. I do want to give you a chance to leave everyone with a takeaway, something they can remember to take home. Not to put you on the spot, but I did give you a little bit of warning before we started. So if you want to share your takeaway with the audience, that'd be great.
Yeah, I guess it could be two things, and I'll just go back to what I said in my talk. Like I just think look, shift left, shift whatever. Like a lot of how we do AppSec does suck for developers, and I think that instead of having a goal of figuring out how to get more security out of teams, I think that has to be like a big negative incentive. Like instead, you should be measuring yourself on how little you can ask a team to do, and I think you should be spending your time figuring out how to get that done. And I think to the extent that you need something like a security champion or a security partner. You need that because you have to translate something. Like, I think you'll know when you've succeeded when you don't need a security champion to explain anything to a developer. I'm not saying I know the whole path there, but I'm saying stop trying to teach them this stuff. Start figuring out more and more about how can I just be in their document, for example? How can I just be in the source code next to them? I feel like this ability to figure out where their whole workflow is about producing this stuff. So I don't want to, again, it's not about hype. It's just these are the facts. Your ability to embed in their workflow and interact directly where they are with very relevant information at each time. This is transformational. Our whole problem is that we're always bothering them with irrelevant shit. And you don't have to do that anymore. That problem is solved now. So start getting to the point where you're adding value to every single deliverable they produce. I think that's a different way to think about it. And I think that's a very real possibility. You could add value to every single thing a developer does. You know what I mean? And Cursor is showing you how to get that done. It's not hard to understand how to get developers to run at you and throw money in your face. It's just show up like Cursor does. It's not a secret. But
Got it. Great. Well, thanks again for sharing that with everyone. Thanks for being on this episode of the Security Champions podcast. Great to talk to you as usual, Jacob.
Likewise.
So thanks for being here. We'll catch up later again soon, I hope. So,
thanks, Dustin.
Take care.